We're going back to the moon because it's the next step in our journey to Mars. We need to go explore the moon. There's vast regions of unexplored areas with the coldest, darkest places in our solar system. This is a test mission, and when we get off the planet, we might come right back home. We might spend 3 or 4 days around Earth. We might go to the moon. That's where we want to go, but it is a test mission, and we are ready for every scenario as we ride this amazing space launch system in the Orion spacecraft.
But another reason we're going back to the moon is to fulfill NASA's mission, which is to explore the unknown in air and space, to innovate for the benefit of humanity, and to inspire the world through discovery. And when we succeed and when we accomplish the things that we set out to accomplish, that inspiration not only can set up new things to happen, but it also is a reminder in tough times that we're capable of doing great things when we work together.
The thing I love about the moon is that it's not just a beacon for exploration and this platform of possibilities for incredible missions like this, but it has benefits. That's actually why we're racing towards it. Those benefits are really wide in nature. You have everything from innovation, technology development, not only for future missions going deeper into the solar system, but technologies that come back to Earth. You have inspiration, a whole generation of people starting this pipeline of STEM workers and manufacturers and operators that are excited to see what you can do when you work hard and you come together as a team.
When I think about the 4 of us flying around the far side of the moon, seeing that Earth rise, taking images and video and sending them back to you, the feeling that I have inside is hope. We know that Artemis 2 is not the solution for humanity on planet Earth, but it is a contribution in the positive column. We hope that just for a moment that people will pause and say, wow, it's extraordinary when you look back upon the Earth with over 8 billion people. And you see this concrete example of what humanity can do, this extraordinary thing when we set big goals and we work together to achieve them.
Thank you, Charlie. This is Victor. We are going for our families.
MS1.
This is Christina. We are going for our teammates.
MS2.
This is Jeremy. We are going for all humanity.
All right, Charlie, your Artemis 2 crew is go for launch. Full send.
I copy that. Reed, Victor, Christina, and Jeremy. On this historic mission, you take with you the heart of this Artemis team, the daring spirit of the American people and our partners across the globe, and the hopes and dreams of a new generation. Good luck. Godspeed, Artemis 2. Let's go.
3, 2, 1, mark. GLS mainline has been initiated.
T-minus 10 minutes and counting.
Right now, the 4-person Artemis 2 crew is 248,000 miles away from the moon. And if all goes well, they will fly by it in 6 days.
GLS is go for core stage to internal power.
All right, there's the rocket's core stage, which houses 3 flight computers, is now on its own power. There's no more hold time because there's no more margin on these batteries. So we would have to recycle back to T-minus 10 to recharge if we had a hold.
One minute.
Right now, the rocket does not know what the T0 is, but coming up at T-minus 33 seconds, control shifts from the ground launch sequencer to the rocket's onboard autonomous launch sequencer, or ALS. The rocket will count itself down, but honor any holds that could come from the ground.
GLS go for ALS.
Great call out. The rocket is on its own. 4 brave explorers ready to ride the most powerful rocket NASA has ever launched. Sound suppression water is flowing.
15.
And here we go. 10, 9, 8, 7. RS-25 engines lit. 4, 3, 2, 1. Booster ignition. And liftoff. The crew of Artemis 2 now bound for the moon. Humanity's next great voyage begins.
Good roll pitch.
Roger, roll pitch.
Houston, now controlling the flight of Integrity on the Artemis 2 mission around the moon.
Integrity, AMT high.
AMT high.
On time passing 30 seconds into the flights. Integrity passes the alternate MECO. Target milestone. Mission Control Houston saying good performance on the main engines. Space Launch System core stage. Integrity, 3 miles in altitude. Traveling more than 1,200 miles per hour. Mission elapsed time, passing 1 minute, approaching max Q.
On, Ponce de Leon.
Stan, we have you loud and clear on Ponce de Leon.
Have you the same?
Communication signal transfer confirmed as Integrity and its crew go supersonic. Approaching 90 seconds into the Artemis 2 mission. Integrity is 14 miles in altitude, 8 miles downrange, traveling more than 2,600 miles per hour. One minute 50 seconds of mission elapsed time, standing by for main engine throttle down to 85%, ahead of solid rocket booster separation, expected at the 2-minute 9-second mark. We see throttle down. Confirmed separation. Main engine's throttling up, guidance converged.
About 2 minutes in, the boosters are released, their solid propellant consumed. The core stage and its RS-25 engines continue to propel Orion and the crew to space.
Integrity, SM priming complete.
SM priming complete.
2 minutes 45 seconds of mission elapsed time into the Artemis 2 mission. Thrusters on Integrity and upper stage confirmed in a ready state, ahead of service module fairing separation.
After 3 minutes, the protective fairings surrounding Orion's service module are ejected, exposing its solar arrays. 6 seconds later, the launch abort system is ejected from Orion. The crew has safely reached Earth orbit, though they could still abort using service module engines.
Standing by for launch abort system jettison.
Houston Integrity, good last jettison, great view.
Copy jettison, Team Eco 8+02.
We see the same on board, Stan.
And Houston has you loud and clear on Tidris at the Carmen line.
Outstanding, Stan, we have you the same.
3 minutes 50 seconds into the flight of Artemis 2, Wiseman, Glover, Cook, and Hansen cross the boundary to space with good comm checks. GPS signals acquired after last jettison now working on internal checks to verify accuracy. Flight Dynamics Officer analyzed the time of main engine cutoff, confirmed at 8 minutes 2 seconds, time of MECO.
Integrity, GPS processing.
Outstanding, Stan. We see the same, and we have a beautiful moonrise. We're headed right at it.
Approaching 5 minutes into the flight, Commander Reed Wiseman confirms he has visuals of his destination. GPS guidance, navigation, and control software finishes internal checks and sends to navigation channels.
Integrity, 3 engine press.
3-engine press.
On time, now passing 5 minutes 20 seconds of mission elapsed time into the Artemis 2 mission. At this point, 3 good main engines are all that's needed to carry Integrity to a nominal main engine cutoff target. Though at this time, we're seeing 4 good engines here in Mission Control Houston. Integrity, 75 miles in altitude, 330 miles downrange, approaching 10,000 miles per hour.
Integrity, looking good at 6 minutes.
Same on board, Stan.
Good trajectory and engine performance. Booster officer will soon report the shutdown plan to Flight Director Judd Friedling, expected at the 7-minute mark. Integrity, 78 miles in altitude, 460 miles downrange.
Integrity, expect nominal shutdown.
Integrity copies nominal shutdown.
Six minutes 40 seconds of mission elapsed time. Shutdown plan is as expected. Again, the time of MECO was confirmed at 8 minutes 2 seconds into the flight. Seven minutes of mission elapsed time. Throttling down as we approach the abort once around option. Milestone at the 7-minute 30-second mark. Now 84 miles in altitude, 650 miles downrange, traveling more than 15,000 miles per hour.
Integrity, AOA open.
AOA open.
The window is now open for an abort once around option that would target splashdown in the Pacific Ocean. Still following nominal ascent at this time. About 10 seconds remaining until the main engine cutoff of the Space Launch System core stage. Standing by for confirmation of MECO and core stage separation.
About 8 minutes after launch, the SLS core stage engines shut down and the interim cryogenic propulsion stage, or ICPS, and Orion separate from the core stage. Orion and the ICPS are now flying free. Orion's 4 solar arrays deploy, powering the spacecraft and charging its batteries for when it moves out of direct sunlight during the journey to the moon and back.
8 minutes 40 seconds into the flight, we have a nominal main engine cutoff heading in the right trajectory on the way to swing around the moon. Core stage has separated, done its job. The Space Launch System upper stage, the interim cryogenic propulsion stage, or ICPS, still attached to the Orion spacecraft. Nine minutes of mission elapsed time. Integrity crew of Reed Wiseman, Victor Glover, Christina Cook, and Jeremy Hansen now in orbit around the Earth at the beginning of their journey to the moon.
After a 90-minute orbit, the engine of the rocket's upper stage, or ICPS, ignites to raise Orion to a high Earth orbit. The Artemis 2 crew and mission control in Houston then began a nearly 24-hour systems check while the astronauts are still relatively close to Earth, familiarizing themselves with their new home for the next several days. Once in high Earth orbit, Orion separates from the upper stage. The expended ICPS and Orion stage adapter serve as a target for a manual handling test called the Proximity Operations Demonstration, preparing future crews for rendezvous, docking, and undocking with other spacecraft. During the demonstration, Artemis 2 astronauts use cameras and line of sight through Orion's windows to pilot the spacecraft as they approach and back away, assessing Orion's handling qualities, hardware, and software. Following the demonstration, spacecraft data is collected to verify system performance, such as life support, communications, and navigation, ensuring Orion and the crew are ready for the voyage ahead. This is Artemis 2. Learn more about Artemis at nasa.gov/Artemis.
Packing for a journey to the moon is kind of like any other road trip. You need clothes, food, a map, your favorite toy? Really? Except this toy has a job to do up there because this is a zero-gravity indicator. While not a scientific instrument, this safe and soft object tells the strapped-in astronauts that they've reached weightlessness. For Artemis 2, the crew wanted a one-of-a-kind ZGI, so we asked you to come up with it.
Thanks everyone for sending in your entries from around the world. Over 2,600 of you submitted.
And we loved seeing all of your contributions.
In the end, we went with one called Rise. It was a design inspired by the Earthrise photo taken on Apollo 8, which is very special to our crew.
With the winner chosen, next came the task of bringing it to life, here in the Thermal Blanket Lab at NASA's Goddard Space Flight Center. This lab specializes in custom materials to protect sensitive spacecraft equipment and is perfect for creating a ZGI that meets the rigorous safety standards of NASA.
Rise ZGI doll. All I have left to do is to close the opening here and hand sew the hat on, make sure its stuffing is stuffed in there, and we have our pocket here for the SD card.
And on that tiny SD card will be millions of names submitted to virtually join the crew aboard Orion.
All right, spaceflight critical hardware right here.
That's a lot of names.
Every single name is in there.
Thanks for flying with us, guys. My nieces and nephews are on that card.
Oh, that's awesome. All right, you guys ready to zip it up?
Let's do it.
All right.
Come along.
Coming ready for flight. Welcome aboard.
Fist bump, guys.
I love it.
Following the demonstration, spacecraft data is collected to verify system performance, such as life support, communications, and navigation, ensuring Orion and the crew are ready for the voyage ahead. About 23 hours later, Orion's service module performs the Translunar Injection Burn, or TLI, pushing Orion out of Earth orbit and on an approximately 4-day trip to the moon. Ultimately, the crew's figure-8 flight path extends more than 230,000 miles from Earth. During the trip, the astronauts continue to evaluate the spacecraft systems and practice emergency procedures like testing the radiation shelter. The Artemis 2 crew travels about 4,600 miles beyond the moon, becoming the first humans to lay eyes on the lunar far side in over 50 years. Their observations will help us prepare for future missions at the moon. During this period, there will be an anticipated communication blackout between mission control and the spacecraft.
a mission specialist.
I'm Jeremy Hansen. I'm a mission specialist.
I'm Victor Glover. I'm the pilot.
I'm Reed Wiseman. I'm the commander for the Artemis 2 mission to the moon.
To the moon.
To the moon.
To the moon.
When I was young, I had a poster of the Earthrise picture, the famous picture that was taken on Apollo 8. And the fact that it was a human behind the lens that made that picture so profound and changed how we all thought of our own home was so amazing to me. The moon is not just a symbol of thinking about our place in the universe. It's not just a symbol of exploration. It's actually a beacon for science. It's a beacon for understanding where we came from.
You know, pushing ourselves to explore is just core to who we are. It's a part of being a human. That's our nature. We go out there and we explore to learn about where we are, why we are, understanding the big questions about our place in the universe. The exploration we're doing is the first few steps on the path of getting humans to Mars.
The Artemis campaign of missions have set such an ambitious goal for humanity that it's inspiring contributions from around the globe. Not just one nation is inspired and moved by this, but nations from around the globe are coming together.
When I look at the Artemis 2 crew with Victor, Christina, and Jeremy, they want to go do this mission. They are keenly driven. They are humble to a fault. It is so cool to be around them. Artemis 2 is a huge mission, but I hope we will look back and realize that this was one tiny step in humans on Mars and a sustained presence on our moon.
Before stage engine start.
Artemis 2 will be NASA's first crewed flight test of the Space Launch System rocket
and Orion spacecraft around the moon.
To verify today's capabilities for humans to explore deep space
and pave the way for NASA's long-term human and scientific presence
on the lunar surface.
We are ready.
We are going
to the moon.
For all humanity, we are Artemis.
It's just everything from the training, but in 3D and absolutely unbelievable. This is incredible.
Kathy Moonjoy.
I definitely see all of the basin of Oriental, Copernicus, easily all in view. This is so awesome.
We look like we're smiling at you, like a little Cheshire cat. I thought we just caught an ActiWatch sync. If I had my own, I'd sync it with you. Breaking news. At this time, you are go for all types of uses of the toilet.
And the crew rejoices. Thank you. We caught a view of Earth in window 1, and now we're completely distracted for a little bit.
To me, is a great, example of why we go and do these missions. If you can't take love to the stars, then what are we doing? Like, why would we even go?
Right now, we see no flow at all.
You are no-go for toilet, and we'd like you to use CCUs overnight.
The space toilet on board the Orion spacecraft is called the Universal Waste Management System. Urine is stored in a tank and then vented overboard each day by the crew. And it does sound like there was a bit of an issue there.
It's kind of a complex engineering issue when you expose a liquid to vacuum. It's a pretty chaotic environment, and there's a lot of theory and textbook work done when you assume it's pure water, but when you introduce the variable of it being wastewater, there's other complex phenomena that we don't quite yet understand that are factoring into that vent line.
We see the blizzard. Cool.
This is a good opportunity to learn now on a shorter mission. If changes are needed to be made to the spacecraft, we have opportunities before Artemis 3 to make those changes.
I like to say that it is probably the most important piece of equipment on board.
Coming up on 1 minute. Mark, 1 minute till crew module, service module separation. And we have confirmation of crew module, service module separation.
Houston, good step on board.
Houston copies and concurs.
The European service module now separated from integrity, a job well done. And the crew module raise burn is underway, a 19-second firing of the thrusters, and we have a completion of the burn. So the final maneuver is now complete. Our trajectory for a splashdown in the Pacific 29 minutes from now is set and will not be amended any further, and we have the right angle of attack to mitigate any excessive heat loads on the vehicle during entry interface. This view from Integrity, as it crosses from southwest to northeast across the Pacific Ocean, 3 minutes from entry interface, and we have crossed the threshold, now entering the Earth's atmosphere. We're at 400,000 feet, traveling 34,800 feet per second. We're 30 seconds away from the anticipated point of peak heating on the vehicle, where temperatures will rise to about 4,000 to 5,000 degrees Fahrenheit. This is the true test of our trajectory. 3.5 minutes left in this blackout period. This is a visualization of the plasma buildup around the spacecraft and the repelling of that heat on Integrity's heat shield. Multiple airborne assets as part of the recovery team all have visuals on Integrity. Landing and support officer reports the small boats are en route to the splashdown target zone.
Integrity, Houston, comm check, post-blackout.
Houston, Integrity, we have you loud and clear.
Your trajectory is nominal, and your recovery teams have visual.
A good view of Integrity, time to splash down 4.5 minutes. And a view of Integrity from the WB-57. We're at 50,000 feet. The pyros are armed for forward bay covered jettison. And there go the first series of parachutes. And we're on drogues.
And Houston, we're visual 2 drogues out the window.
2 good drogue shoots. Next up.
We copy, we see them.
Next up, the deployment of pilot parachutes that will pull the main chutes out. Time to splash down 3 minutes and 10 seconds. Perfect descent rate according to flight dynamics.
Good rates on 2 drogues.
We see the same on board.
Passing through 10,000 feet. Main chute deploy. We're at 5,000 feet. Search and recovery beacon has been activated on Integrity. Good 3 main chutes, good reefing, good descent rate.
Good rates, and we see 3 good-looking parachutes.
This is a perfect descent for Integrity. Its crew sounding hale and hearty on board. Time to splash down 1 minute, 15 seconds. Integrity about to complete a journey spanning 694,481 miles from its launch from the Kennedy Space Center back on April 1st, and a trip around the moon. Passing through 1,000 feet.
Houston, Integrity, splashdown, sending post-landing command now.
Splashdown confirmed.
Copy splashdown, waiting on VLDR.
Splashdown confirmed at 7:07 p.m. Central Time, 5:07 p.m. Pacific Time. From the pages of Jules Verne to a modern-day mission to the moon, a new chapter of the exploration of our celestial neighbor is complete. Integrity's astronauts back on Earth.
This is Artemis 2. Learn more about Artemis at nasa.gov/Artemis.